Hello, everyone. As you mentioned, my name is David Beard. I am a senior product manager primarily for tools, independent software vendors. And also, I'm the developer evangelist for the Vuforia platform. I've been with Vuforia for about 5 years now, from the time that we had come out of what was an R&D group for developing computer vision algorithms for mobile devices, now through our acquisition by PTC. Vuforia's focus has always been to take best-of-breed computer vision and to build it from the ground up for mobile devices and now what we call digital eyewear, which is really wearables, both optical see-through and video see-through devices. What I'm going to show you is classes of experience that we have begun enabling for eyewear, and also some different use cases that people have been building using our SDK and the platform. And then I'll get into, not a deeply technical talk, but I'm going to review really the features that we've introduced recently with our 5.5 SDK and some of what they enable so that people that are thinking creatively about mixed reality can have an idea of what's capable or what's possible. So, you know, we're obviously hearing a lot about AR, VR. Both of these are technologies that have been emerging for some time now. And there have been prior generations of development, specifically in VR, but also in AR, somewhat more behind the scenes. And so you're starting to hear the term mixed reality, and there are different definitions for that and different visions behind what constitutes mixed reality applications. Vuforia is really in a position of enabling both AR and VR and enabling a new type of mixed reality that really converges the capabilities of these technologies so that they're both complementary, but that they can extend each other in a way that I don't think that people have recognized before. So that'll be an aspect of what I think colors some of my description of the technology. Just as some background, as I mentioned, Vuforia has been instrumental in developing computer vision for mobile and wearable devices. Our SDK is really focused on augmented reality. And what this means is AR is the ability to recognize things like images and objects, to recognize features in the environment, and actually provide you an understanding, a certain intelligence about what you're looking at. So it can uniquely recognize something, but it can also tell you exactly where it is in relation to the user within the field of view of the camera. And the principle of augmented reality is that you're recognizing something, you know where it is, and then you're rendering virtual content onto it. And you're doing this in a way that looks realistic to the user. And what this means is that it has to follow the user as they move, and it should be at the right distance, and it should have the right sort of behavior that you would expect of a real object that exists in the real world, but this is being rendered digitally. So the platform has focused really on the recognition of images, of stable geometric objects, and this is things like toys and you know, smaller models. A lot of our stuff, because it originated with handheld devices, has been what you might call a tabletop experience. Really viewing distances equivalent to what you might use to watch a television, or that might be on a tabletop, you know, like a coffee table, something like that. But images and objects, also we have text recognition, and we have the ability to infer the geometry of an environment. And what that means is that using a handheld device or using eyewear, you can actually construct a representation of the physical setting of the user and do something interesting with that. You could use it for gameplay or to do product visualization, things like that. So the platform is really broken into 3 primary components. The first is the SDK. We have SDKs for Android and iOS. We're introducing support for Windows 10 as well, UWP apps. You can do native development in Java or C++, and you can also work in Unity. About 85% of our developers work in Unity. Unity is a game development engine. It provides a visual authoring workflow, so it's attractive to people that are doing the range of interactive design, modeling, game development. It's a very easy environment to get started with. When you're creating what we call targets, which are really objects or images or settings that are predefined, you do that online using the Target Manager, which is a web tool for creating and managing targets. And then we also offer tools for scanning objects to create targets from those. And for eyewear, there's a specific tool that provides for calibration of the eyewear. It's a bit like getting a prescription for your glasses. It just makes them more accurate for the user. And then we have a cloud offering where for parties that have large portfolios of images, let's say they're running their own content management system, maybe they're doing publishing, or they have, for whatever reason, like real estate images, something like that, where they have up to 1 million images, you can put them in the cloud service. And that really provides the same capability as the SDK, but it's acquired remotely. So let me start talking about our mixed reality offering. As I mentioned, we started with mobile devices, so those are handheld. And we moved into support for optical and video see-through. And so these are kind of technical terms, but what they mean, an optical see-through device has a transparent lens. It's something like the Microsoft HoloLens that you've probably heard about, or Mavario's or Epson's BT200, BT300. These are devices that are gaining a lot of popularity because they basically provide a hands-free experience for the user when they're viewing the real world around them. So they're getting a lot of traction in workplaces and also for casual applications like gaming. There's another class of eyewear that's known as a video see-through device. And this is like a Google Cardboard or a Gear VR. For these, you're actually using the lens, the screen of your smartphone as the viewing display for the user. So you take them, you slip them into a cradle, and you're basically looking at the screen of the device and using the camera to see the world around you. And so that's how we support AR, is that we use the device as the display and we use the device camera as a view of the world, basically. So with these capabilities, what we've introduced, and this is really with Vuforia 5.5, is support for what we call mixed reality. And as I mentioned at the beginning of the talk, people have different definitions of this. I'd like to sort of clarify what we do with this and show you how it's valuable. I think this is compatible with people's understanding, but it's also a new take on it, so it's important to understand. Now, with VR and AR, they really have a similar technology stack, meaning that they're using similar classes of hardware. They have certain requirements that are similar for things like rendering or use of sensors, use of cameras. So they're really complementary that when you're developing solutions for VR or AR, you're using a similar skill set and you're relying on a similar underlying capability really within devices and also for tools. The distinction is really they have different levels of immersion. So VR is fully immersive. You're entirely in a virtual world. Everything you see is being rendered digitally. AR obviously doesn't do that. It's actually showing you the real world and it's bringing in virtual elements as a complement to that. And we think that they're complementary. There's a couple of basic uses that we've seen and that we promote to developers, but that we've seen people take up on their own. And let me just explain these. So you have to consider when you have an AR target, what you actually have, even if you're in VR, is that you have a representation of the real world that you can track even in a virtual reality setting or in a virtual reality experience. So you can use your knowledge of the physical environment or of a handheld target as something significant in the VR scene. Whether you're telling a story or playing a game, you can make the target that the player is holding a proxy for something or a prop in sense, so that when you take it into VR, the user has an ability to control aspects of the environment using augmented reality, even in a fully immersive environment. And an even simpler application of that is what we've seen specifically with a lot of the video see-through, is that it's comfortable for users to start a VR experience in AR because they can see the world around them. They're not throwing themselves into a VR immersion. They're not throwing themselves into an experience that's entirely foreign to them. So I'm going to show you some examples of this. So the first here, this, if you remember the Mattel Viewmaster, and this I think was developed in the 60s or so, but it was really a stereo viewer, right? And they gave you these experience reels and you put on this headset and it gave you sort of a 3D view of the Tower of London or something like that. So they have been working with us really using the SDK to provide a type of AR or VR experience that shows how you can gracefully transition from AR into a VR experience, and you can use it as a way of selecting what kind of content you'd like to use, and also just for sort of situating the user and moving them into VR. So let me show you this. So as you can see, you slip the device in, you view the experience disk, and then you're using that to really select which of the content you'd like to see. Here's the Golden Gate Bridge. But they've done very well with this. And basically what the model here is that they sell you the viewer, and then they'll sell you these experience discs as packs, right? So you're extending the capability of the viewer by buying new content, essentially. Realiteer is an independent developer. He's showing here how you can use a target as a type of controller in a VR experience. So he's using Vuforia to recognize that handheld target, and then it serves as a gun in the game that he's developed, where you're shooting, I think, boogers or something. You're shooting something. Oops. There you go. So you can see he's using cardboard. And basically, he's just using the SDK here to track the position of the gun in the scene. And it enables for a very easy-to-use sort of AR/VR experience that's primarily immersive, but uses AR as a way of extending the capability of the VR app. So the third case here, this is Courty-Orly. There's near the Courty-Orly airport in France, there's a real estate development that has taken, really developed what we call a dual mode application. So this is an app that works both as a handheld app and can then be slipped into a cardboard viewer so that you can use it for VR. What they do is that they look at, really, it's not a schematic, but it's like an artist's representation of the development, and they augment that in AR. They look at basically what are interest points on the development, and they select those through AR and then transition into VR to get a panoramic view of the interior of the development itself. So you can see he's augmenting the map there, selecting an interest point, and then going into a panoramic view. So just to recap, again, what we're enabling here through mixed reality is the ability to develop both AR and VR apps that can transition from AR to VR and back and forth, and also to use the capabilities of AR tracking in a VR application so that you can make the real world significant within the VR experience. Now, as of Vuforia 5.5, we've introduced capabilities that are really specific to support for virtual reality. This is a lot like what Cardboard is providing or what Gear is providing, but this really gives developers an independent solution that isn't, you don't have to go and get somebody else's SDK to do it. So really, the core capabilities have to do with stereo rendering. This is the ability to render binocularly, so for two eyes, so that you get the sense of depth as though you're looking through both eyes. Oh, okay. Also, rotational device tracking, which is the ability to track your head as it moves around. What this means is you don't have to use the camera, but it's able to follow the position of your head. And then a mixed reality controller API, which is really for developers. It's just an easy-to-use utility API that enables you to develop mixed reality applications without getting into a lot of the plumbing behind it. It's just a simple-to-use convention for programming these. So stereo rendering supports digital eyewear apps, high-fidelity rendering on a range of devices. We support everything from Cardboard to Gear VR. You can custom configure those, so if you're developing your own headset, you can actually customize the parameters here. Rotational device tracking, again, enables you to follow the user's head, and it also supports hand tracking. So if you have an application that you want to make the phone essentially a type of device or controller, you can use rotational device tracking as a handheld tracker, and you can also customize these as well. And then again, the Mixed Reality Controller API is just a very easy-to-use API to manage and control the life cycle of a mixed reality app. That's it. Any questions? All right, thanks.